Good morning, everybody. In this video, we'll talk about the amount of energy needed to lift an object from the Earth's surface. So let's say this is the Earth surface, and we have an object of mass m, and the mass here is 5,000 kilogram, and we have to lift this mass to a height of 600 kilometer above the Earth's surface. How much energy we have to apply? The one may think of the answer by simply by using this equation, the potential energy equation mgh. But remember, here in this case, the g is not constant, because if we keep moving up, the value of g starts decreasing. So g is not constant. So the equation, the potential energy equation, this is the gravitational potential energy equation, mgh. This is true. This is true only to the close to the Earth's surface, or the g value does not change much. But if we take to a significant height, here in this case 600 kilometers, the g value would change. When I say g value, that means acceleration due to gravity value. So in this case, we have to use a different formula. Or in other words, we have to find out the change in potential energy. So let's start here. First, we're going to write down all the given values. So here, the mass of the object is given, which is 5,000 kilogram, and we are moving or lifting to a height of 600 kilometer. And remember, every time we need to change the kilometer to meter. So this one would be 600 times 10 to the third meter. Everything has to be expressed in terms of scientific notation. The mass of the Earth is given, that's the standard value. Even if it is not given, I would recommend to remember these values, which is 5.96 times 10 to the 24 kilogram. The radius of the Earth is also standard, is given 6.37 times 10 to the 6 meter. And now all we have to find out how much potential energy is changed from between these 2 points. All right. So the change in potential energy would be given by the final potential energy at this point and the initial energy at this point, the change. And what is the equation for the potential energy? So remember, the potential energy is given by G m over R, and I'll explain each term here. M here will be the mass of the Earth. M in this case is the mass of this object here, and R is the distance between the two objects. That means from the center to this point here. Or we can write down this distance in terms of the radius of the Earth plus the height. That is the equation for the change in potential energy, the potential energy equation. So first we have to find out what is the potential at this point here. Okay, so the potential at this point will be G, which is the universal gravitational constant, the mass of the Earth, the mass of the object, divided by the distance between these two objects. And now if you look at the potential energy at this point, it will be simply equal to G, the mass of the Earth, the mass of the object, divided by the distance between the two objects, which will be the radius of the Earth. And remember, the distance is always measured from the center to the center, or in fact we can call center of mass to the center of mass. Okay, so the center of the mass of the Earth is right here at the center of the Earth, and this object has a center mass here, so that will be the distance between the two objects. And now this one becomes very straightforward. All we have to do is plug in all the values. So in order to make the calculation easier, what I'm going to do, I'm simply taking out G, M, E and M from out, because it is common in both terms. and it will reduce to 1 over Re plus H divided by Re. And we know all the information. The G is the universal gravitational constant, that's value is here. The mass of the earth, that's value is here. M is the mass of the, I think it has to be 5,000 probably. 5,000. I think I missed 1 0, so I'm getting 5,000. And Re is the radius of the earth, H is the height, which is 600 kilometer, and Re is again the radius of the earth. So once you plug in the number, you will get is this number here, this number. So we can understand this energy in terms of the electricity we consumed in our house. So if you look at the US, average energy consumption in a month, so it is about 900 kilowatt hour. Okay, 900 kilowatt hour in a month, the average household energy consumption. So in terms of energy, it will be 3.24 times 10 to the 9 joule. So the energy required to lift, let's say call a satellite, just to lift a satellite from the earth's surface to a height of 600 kilometer, we need about 1 month of energy consumption. Okay, sorry, 10 months. 10 months equivalent of electrical energy consumption. That means the amount of energy we consumed, electrical energy we consumed in 10 months, that amount of energy will be required to lift an object from the earth's surface to a height of 600 kilometer. Okay, so this is it from this video. So on summary, if I have to mention, if you need to find out the amount of energy required, all you have to do is calculate the change in potential energy. Okay, and if someone asks you what is the amount of work done required, so remember the work done required is always equal to the negative of the change in potential energy. So work done is equal to change in potential energy. If you have to find out the amount of work done, that is the amount of the work done required. So this is it from this video. If you have any questions, write down in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.